All right, so the next thing we're going to do is look at addition and subtraction of complex numbers, okay? So maybe we want to take a plus bi plus c plus di, or maybe a plus bi minus c plus di. Well, what we're going to do is we're going to add the real parts, and we're going to add the imaginary parts, okay? So here we'd have a plus c is going to be our real part. And now since we can remember, if you have something like bi plus ci, that could be I times b plus c. We just factor out that common term of I. And so that's how it's going to work here. We have bi plus di. Well, b plus d we can pull out in front, and then we have the I still on the end. And so it's just a plus c, then plus b plus d times I. Okay, and the same thing works here, except now we're taking a minus c, and so we get the a minus c, plus, we're still going to have plus here because really what's inside here is where the subtraction goes. And then we have bi minus di, so we have b minus d, and so that part goes here, and times I. Okay, so now what we're going to do is we're going to look at adding or subtracting. And again, it just depends on what your value is here. And you can have negatives up front and positives back here or wherever, and you just have to follow kind of the order and see what's there. So we have a real part here, an imaginary part here. So based on that, we have a -2 plus 1 plus, and here we have a -4 and then plus 6 times I. Okay, now we simplify. -2 plus 1, well, that's going to be a -1. And then 6 minus 4 is 2, so plus 2 times I. And that then is our final value. Now, don't forget to keep your I here, because if you just have -1 plus 2, well, that's actually 1. But then this has the I on it, so then you have this kind of binomial, a two-term thing, okay? All right, what about the next one? Again, this time we're just looking again, but we have that negative there. So we're going to take 2 minus 3 plus, now we have a -3, and then we have minus 2 times I, okay? So that's not too hard. And so now we just say, oh, 2 minus 3 is -1, so we get a -1 again. And then a -3 minus 2, well, that's -5, so we can just say minus 5I, okay? All right. Now, how are we going to look at this? You know, if you're having trouble with the i's, think about it. You know, what if we had, say, 2 plus x plus 3 plus 4x? So same concept, but now instead of i's, we have x's. We know how to use x's. That's not a problem. We just take 2 plus 3, and we get 5. And then we have 1x plus 4x, and that's 5x. So, you know, we've been doing this already, but now we're taking it one step further and saying, well, these are imaginary numbers. So we have that I on it instead of just the plain x. And the same thing works if we had, say, maybe 2 plus x, and then we had minus 4 plus 3x. So let's change this side up a little bit and do that. So we still would do 2 minus 4, that's minus 2, 1 minus 3, so it's going to be minus 2x. Okay, and again, we know how to do things with x's because we know those are just like terms. We just add them together, and so we have to think of these as like terms. You know, the constants only and the imaginary parts only. So it works both ways, and so hopefully that'll help you kind of realize that, hey, you know, it's nothing different than we've done before with our x's, but now we have to have that imaginary part included there. Okay. All right, next is multiplication. So we've done addition, subtraction. So next multiplication, probably after that's going to come division, you know? And so what we're going to do is we need to, it's going to be simple. We have a real number part and a complex number part, and we're just going to distribute and simplify. So this is the simple way. We just distribute rainbow. Or we can do multiplication by doing two complex numbers and we FOIL basically and then simplify. Okay, so, you know, this one is going to be FOIL, and if this one we have just a number and a complex number, then we just distribute and do it. And really, you're doing the same thing here, but we have a fancy name called FOIL for it. So what do we do? Well, we're just going to do the rainbow. We're just going to multiply like this, okay? So it's a -4 times 2? Well, that's a -8. What's a -4 times a 6? Well, that's -24, if I can write it. And then we still have times I, or with the imaginary part, just I. Okay, so minus 8 minus 24i. And that then is our final answer. Now this next one here, it's going to introduce something that we have to go clear back to that first slide because we have I times I, which is I squared, and we don't want to have I squared in our final value. We just want to have only an I. So we have to convert that I squared. So let's first do the foiling part. So we'll take first 3 times 2, that's 6. So if we want to write it out, we can, do this, and then we're going to do this. So we can write it out like that because that's really what foiling is doing. So this would be, first, and then we have outer, I guess F, and then outer, and then we have this is inner, and then this is last. So that's really what the FOIL is. Now let me write my 6 a little lower so I can continue on. So the first is 3 times 2, which is 6. Outer is 3 times 3i, which is going to give me plus 9i. Now my inner is 2 times negative 4i, so it's going to be minus 8i. And last is going to be a negative 12 times I squared. Okay. Now, does anybody remember what the I squared was? Well, if not, let's go all the way back here. I squared was equal to that negative 1. So we come back over here now, if I can find it. There we go. I squared is negative 1. So let's write that up here so we remember it. I squared is negative 1, so we're just going to replace that with the negative 1. Well, what I'm going to do is I'm going to start adding as I go across. So I'm going to be 6, 9 minus 8, since those are like terms, that's going to be 9 minus 8 is 1, so that's just going to be plus I. And then I have a minus 12 times, well, that is negative 1, okay? Now I have a negative times a negative. Well, what does that do? Well, if we take a negative times a negative, guess what? That becomes a positive. And so now we can say, well, this is equal to 6 plus I plus 12. And now I have like terms again. 6 plus 12 is 18 plus I. Okay, and then that would be my complex number to get after I FOILed these two complex numbers together. Here I just took a constant times a complex number. Here I took two complex numbers. All right. The next thing is called a complex conjugate. So what does that mean? Well, it's a complex number where imaginary part has the opposite sign as the original number. So the conjugate has that opposite sign. So if we start with a plus bi as our original complex number, then it says the opposite sign on the imaginary part is what the conjugate is. So if we change the sign to negative, that then is the complex conjugate, okay? And so all we did was we changed our sign, okay? So, if we think about that, a plus bi and then a minus bi. Or what if this was actually a minus bi as the original number? Okay, well, then we need to change that to a plus bi, and that's going to be our complex conjugate. So it can go either way depending on what your original complex number was, if either plus or minus. Then the other sign is going to be either a plus or a minus depending on what you had. So all I want us to do here is find complex conjugates. So what we need to do is we need to change that to a plus, and then we say 3, and then we can I square root of 7. Okay, and again, you could take square root of 7i, but sometimes, again, what happens is when you do that, I can't exactly tell if that's under the square root or not if you have it too long. And the computer, if you forget to say stop the radical and put it out here, that will give you a wrong answer too. So it's better to put, when you have radicals, that I out in front. Okay. So that one we changed from a negative to a positive. Well, here, really, what is this? Well, that's 0 minus 2/3 I. And so that's our original. So what we're going to do is it looks like this. So we're going to change it to a 0 plus 2/3 I. And then if we go ahead and drop that 0 again, that's just 2/3 I. Now you could have gone straight from here to here, and that's fine. But I wanted to kind of show you that really this is the whole complex number. And so, sometimes people, when it's not in the same form as they're used to, as the a plus or minus bi, then they don't know what to do. And so that really was just the bi, and it's the bi part that we changed the sign on. And so we had to change it to a plus, and then we could drop that 0 after that. Okay. Let's see here. How about the next page? We're back to the division. So this is really what we need to do, and we need to understand finding the complex conjugate to be able to do division, because that's what step 2 is. So we're going to write division as a fraction, and so that's the easiest way. So if you actually have, say, 5 plus 2i divided by, 3i or something like that, what we need to do is we need to convert it into something like this. Okay, and that's just going to make things a lot easier, because what we're going to do is we're going to first determine the complex conjugate of the denominator. So if this is the original complex number, the complex conjugate is a negative 2i. Okay, so we've determined it here. So the complex conjugate is a negative 2i. Okay, now we're supposed to next multiply the numerator and denominator by the complex conjugate of the denominator. Well, that means we're going to multiply by a negative 2i over a negative 2i. That's not hard. We can do that. And then what's going to happen is when we multiply by the conjugate, the complex conjugate, we're going to get an I squared. And remember, I squared is a negative 1. And so what happens is it starts canceling a lot of stuff out. So that makes things really nice for us. All right. So what we need to do now is we need to do multiplication. And if we need to, what we can do is we can rewrite this as a negative 2i times negative 5 plus 3i over 2i times a negative 2i. Okay, it doesn't matter how that is. Well, now we can FOIL this pretty easily. A negative 2 times a negative 2i rather times a negative 5 is going to be a plus 10i. And then here we have negative 2 times a 3, so that's going to be minus 6. Then we have I times I, so it's going to be I squared all over 2 times negative 2 is negative 4. And then we have I times I, so that's I squared. Now remember, I squared is negative 1, so that's a 10i minus 6 times negative 1 over negative 4 times negative 1. Well, here negative times negative is positive, so that's a 6. And remember, our standard form is a plus bi. It could be a minus bi too, but so we want the a out front. So this is the a, so that's a 6. Then plus 10i minus 4 times a minus 1 is going to give me 4. And so that is pre-reducing, because now if you think about it, can we reduce this? Well, here, this 4 has 2 times 2. This is 2 times 3, and this is 2 times 5. So what we could do is we can cancel that 2, and that 2. Now, whatever you do on the bottom, you have to do to both parts of the complex number on the numerator. So then you'd have 3 plus 5i over 2. Let's go ahead and write that 3 plus 5i over 2. Now, sometimes we want to write it and split it, and so that would be 3 halves and then plus 5 halves I. So, again, if we're writing it as the a plus bi, that has to be what it is, because you have to have the whole A and you have to have the whole B, and that's the only way to do it. Because if you have it like this, you'll understand what it is, but this is going to be the actual final value you want to have for this one here. Okay. So let's do some division. So let's change back to purple. And so we need to first remember, find the complex conjugate. So complex conjugate is equal to what? Well, it's going to be 4 minus 3i, because again, we just take the opposite of the sign here and we put it for the conjugate. And so we're going to multiply by 4 minus 3i over 4 minus 3i. Okay, so now you can see why we needed to learn a little bit of multiplication before we got to the division, because division is just multiplying by the conjugate on numerator and denominator. All right, so FOIL. I'm just going to do it, here without rewriting it all and then drawing the arrows. So I'm going to take first 2 times 4. That's 8. Outer, 2 times a negative 3i. Well, that's going to be negative 6i. Inner, negative 3i times 4. So that's going to be a negative 12i. And then last, a negative 3 times negative 3 is plus 9. And then an I times I is I squared. Now the denominator, we have 4 times 4, that's 16. Outer, 4 times a negative 3i is a negative 12i. Inner, 3i times 4 is going to be plus 12i. And then last is 3 times negative 3, so it's a negative 9, and I times I is I squared. Okay. So now the next step, we can do kind of two things at once. We can add things together, which in this case, we add those two together and we add those two together. And so we have 8, that's going to give us minus 18i, then plus 9 times negative 1. Okay, so we're going ahead replacing I squared with that negative 1. Now here, guess what? That cancels that, so we're out of i's, and so we have 16, and we have minus 9 times negative 1. Okay. Well, what can we do here? Well, it's going to be 8, and then basically minus 9. 8 minus 9 is going to give me a minus 1, and then minus 18i over. Here, a negative times a negative is positive, so we have 16 plus 9, which is 25. Okay. And again, we want to have it in the form a plus bi, and so we have to split this fraction apart into a negative 1 over 25 minus 18 over 25 times I. Okay, and so then that would be our complex number from the division of 2 minus 3i over 4 plus 3i. And so that would be our final answer. All right, let's pause there and we'll come back for more.